Hey Algebra 2 friends, we're in section 8.3, circles. Our vocabulary starts off with the idea of what is a circle, and I think you know what a circle is, but for our all intents and purposes, and so we can kind of consider the equation, a circle is a collection of points equidistant from one point on a plane. There's a video that I like on YouTube that really sums this up really well, so I'm going to let that play for a little bit.
And the best way to understand what that means is to see it in action. So, here's a single point to start with. And now, let's start drawing points that are equidistant from it. This point is a foot away to the right. Now let's make another point a foot away, but in another direction. Let's say up here. Now let's make another one, also a foot away, but in another direction, right here. Now let's make another, right here.
And another.
Phew, I'm getting tired. But do you see what's happening? The more equidistant points we add, the more the pattern looks like a circle. And that's why a circle is defined as the set of points that are equidistant from a center point.
So I'm also going to steal this little picture from that video. I really like that video, by the way. If you're ever having some mathematical difficulties, or if you know a friend who is, Math Antics is a wonderful resource on YouTube. All right, so with that in mind, all of the points equidistant from one point on a particular plane is going to create what we call a circle. And so that's what a circle is. I'm sure you knew it, but I just wanted to define it in maybe a different way. The center is the point that we start off with, the one in the literally the center. And the idea of tangent is really a relationship. To be tangent to a circle means that you pass through exactly one point. See if I can get this to work. One point on the edge of the circle. And so you might have a line that is tangent to a circle at a point. You could also talk about a shape that is tangent to a circle at a point. We have in mathematics two concepts that we use the same word tangent for. So you'll look out for that when we start talking about trigonometry. But in this case, tangent is that relationship, passing through one point on the edge of a circle. So here we come to the first key concept of the section, where we are given what we call the equation of a circle. And we're going to talk about it in reference to what a circle is. The equation of a circle, where HK is the center and R is the radius, is given as follows. X minus H quantity squared plus Y minus K quantity squared equals R squared. You might look at this and think that it looks kind of familiar. Your eyes might make you think of a couple things. Maybe the Pythagorean theorem that we've talked about, a squared plus b squared equals c squared. It has that vibe. But in addition, it also has the vibe, and let me write it this way. D, the distance formula, is equal to the difference between the x values squared plus the difference between the y values squared, square rooted, right? And so if I squared both sides of that, I'd again have this situation. Well, that's really what's happening here. And you can see that this kind of looks like the distance formula, x minus h, right? X minus h would be the distance from here to here, right? And then y minus k would be the distance from here to here. And if I had this squared plus this squared, it has to equal to the hypotenuse squared from the Pythagorean theorem. If you want to talk about that more, if that doesn't make sense, definitely talk to me. Let's make sure it makes sense, because it's just nice to see the compact information, how that all travels. So every xy around this point has that relationship with HK, that center point, and that relationship is a distance of R. So let's go ahead and look at our first example. We're going to write an equation given the center and the radius. So in 1986, a nuclear reactor exploded at a power plant about 110 kilometers north and 15 kilometers west of Kiev. At first, officials evacuated people within 30 kilometers of the power plant. Write an equation to represent the boundary of the evacuated region if the origin of the coordinate system is at Kiev. So here is the information I got just from looking at the problem, just from the words here. We were told that the center is Kiev. That's how we're going to orient our X and Y axis. And we were told to write an equation now to represent the boundary of evacuation. And so that red dot represents the point of the nuclear explosion. And so we were told that is 110 kilometers north and 15 kilometers west of Kiev. So that gives us that location there. And that point would be negative 15, 110, right? 110. And then now we need to consider the next part, this 30-kilometer radius. And so that means that we would be stretching out 30 kilometers this way, 30 kilometers this way, 30 kilometers this way, and 30 kilometers this way to make I'm going to try to give myself an opportunity to make kind of a circle like this. So we need to try to represent this situation, this circle that I'm attempting to make that's coming out a little bit more blobular, but you get my idea, right? You get where I'm trying to go with this. Okay, that's as best I'm going to do. So we need to make an equation for that. And so we remember what the general equation is. The general equation for a circle is going to be, not too big, x minus h quantity squared plus y minus k quantity squared is equal to the radius squared. So what is x here? Well, x is just every point. X and y refers to every point. So we write down the x. That's going to be written down in our equation. And we need to make sure the y is in our equation. But those are the only two variables we'll have. Everything else needs a numerical value. So our equation, I'm going to change the color so you don't think that that blue is 110 is a part of it. Give me 1 second. I just noticed it looks very confusing if you were to walk up and say, what is that? Why is that equation there? Okay, so I'm going to change it all to blue so you know I'm talking about something different. And so go back, x minus h. What is h? H is the x term. X minus a minus 15 is going to be x plus 15. You with me? So quantity squared. Y minus 110 is just going to be that y minus 110. And r squared is going to be the radius. The radius is 30. 30 squared would be 30 times 30 or 900. And so, oops, squared right there. So this that I have blocked off, trying to still not include that 110, this is the equation that we're looking for here based on the orientation that we have there. Make sense? All right. Here we have a trickier situation where we're going to be writing the equation of a circle given two endpoints, not the center, right? So let's go ahead and remember what our equation is. Not x minus y, but x minus r. Nope, just kidding. X minus h quantity squared plus y minus k quantity squared is equal to r squared. Remember, this is something that you want to memorize. And so we have this said circle such that we don't know where the center is, but we know that one point is at a positive 5, 4. And some other point is over here at a negative 2, negative 6. I'm not going to draw the x and y axis. I'm just going to draw this just so we can kind of get an idea of what's going on. So here's our situation. It's on the coordinate plane. We need to know the center. And the best way for us to get the center would be for us to consider the fact that this is a diameter. All diameters pass through the center. The center's here. How do we find that point? The center is not just any old point. It is the midpoint of the segment that connects those two endpoints, right? And so to find the midpoint, to find this guy here, which is the center of the midpoint, we add up the two x values, and then we divide by 2. 5 plus a negative 2 is 3. 3 over 2. I'm just going to leave it as 3 over 2. And then 4 plus a negative 6 is negative 2. Negative 2 over 2 is negative 1. And so now we have the center. We can go ahead and rock and roll. Well, almost. We'll get there. So we're going to need the radius. That means we're going to have to use the distance formula to find that. Or we can find the distance from here to here and cut it in half, whichever one you like. Okay, so the first thing I did is I put in the center point, that HK, minus 3 over 2 minus a minus 1 becomes a plus 1. Y plus 1 quantity squared. Now we need to find the radius, which we said uses the distance formula. I'm going to find the distance from these two, from the center to the edge. So I'm going to pull out D is equal to the square root of, you remember, x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. All right. So this is what happens when we plug in some values. We get this, and this is going to become 5 minus 3 over 2 is going to be 5 minus 1.5. It's going to be 3.5, right? 3.5 quantity squared plus 5 quantity squared, which is 25. So with a little math and help from my calculator, I got 37.25, the square root of. That's the distance, right? And that means that's the radius, right? We can also call that the radius. And if that's the radius and we need the radius squared here, the radius squared here, the radius squared here, that just means take the radical off. So then this becomes 37.25. And that's our equation. So in this problem, we are asked to find the equation of a circle given a little bit of clues about what's going on with this circle, okay? So we're told that the center is at -4, -3, and we're told that the circle is tangent, there's that word, tangent to the x-axis. So since here's the circle, here's the center of the circle, that's -4, -3, and tangency, we know it means it just touches the x-axis, right? So it just touches, it goes through at one point. The x-axis goes through at exactly one point. So we should have a situation that looks like this, something of that nature. Now, what that tangency does, what that information does, is it tells me that the distance from the center to the edge has to be whatever this distance is. And it really tells me that it's 3. Does that make sense? If this circle has a center at -4, -3, and it's tangent to this point, then that really does tell me that the distance from here to here has to be 3. Another point in terms of tangency is that there is a perpendicular relationship. Anything tangent to a circle at a point is going to have a perpendicular relationship, particularly a line segment or something like that. So with that I'm confident that this radius is 3, and so with the radius being 3, this is easy for me. I'm just going to use this formula by plugging in the information I have, recognizing that h is -4 and k will be -3. I get x plus 4 quantity squared, y plus 3 quantity squared is equal to 3 squared, or I could have written that 3 squared more conveniently as 9. And that's the equation of that circle. Now we're given a pretty simple equation, but sometimes simple equations can be deceptive. So we know that we have memorized x minus h quantity squared plus y minus k quantity squared is equal to r squared. And here's the equation of a circle. It's got x squared plus y squared equals 25. You can safely assume that 25 refers to the radius squared and that the radius in this case is 5. But here it's like, well, what is h and what is k? You notice that x has nothing being subtracted and y has nothing being subtracted. And when we think about that, we're thinking about nothing as 0. So we can actually rewrite this equation in this way, which emphasizes the fact that hk is 0, 0, or the center is at 0, 0, right? So we have a center at 0, 0 with a radius of 5. Let's graph. Start with the center of your circle right there, and then march out 5 spaces on each axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, and then we're going to do it in the last direction. And after we do that in all 4 directions, now we're going to try to just make what amounts to a pretty decent circle around there. I'm sure you can do better, but that's it. That's all that we need to do. This next problem isn't super hard, but it requires a little bit more time. So I'm going to stop the video here, let you kind of digest the information, and then we're going to talk about this one. I want you to put your completing the square hat on to talk about this next problem.